Students, welcome to my class in nuclear physics. Today we will be discussing nuclear fission, which is, as you know, a very important process. Let us look at the history. In 1939, Hahn and Strassman were the two scientists who discovered this phenomenon, and what they saw was this can be represented by this particular equation. This is a nuclear reaction in which uranium is hit by a neutron, and as a result barium, krypton, 3 neutrons and some energy in form of gamma rays were emitted. So let's take a closer look at the whole process. So actually this is the first nuclear fission that was done. But then there are different types of fissions which we will come to know after this. So this is the equation that we had just seen. So what happens is that, let's revise. If I have a uranium nucleus, so this is uranium, and what is uranium-235? 235 is a particular isotope of isotope of uranium, and when this is hit by a neutron, then what happens that it breaks up like this. It breaks up into two parts, barium (56) and krypton 36. So obviously these are the atomic numbers out here, and then 3 neutrons are also released. These are all neutrons. So these are neutrons and energy in the form of gamma rays. So this is what happens, and this is fission, as we all know. Now students, there might be a question that is this the only fission? Of course this is not the only fission. This is the first fission that was experimentally made possible actually. So whenever you have a large nucleus, that means what? A nucleus which has got a big atomic number and a mass number like this, because this represents the number of protons plus the number of neutrons, so it must be heavy. So this has to be big, and then when it is hit by a neutron, then again the question may arise that does it always require a neutron to hit it? No. Now it has been found that fission is possible also by hitting with different particles such as protons, neutrons, which we have already seen, then by deuterons, alpha particles, electrons, and gamma rays. So now we know that yes, this element which has to undergo fission can be any element, but then certain conditions are to be satisfied, and then this particle can be any of this one particle. If you remember nuclear reactions, you know that this can be written as x plus x goes to y plus y, where x is the target nucleus. In this case uranium is the target nucleus, and it is hit by small x, which is the incident particle, that is the neutron, and as a result this time we have more than one particles. We have the barium and the krypton, so we have 2 y and y dash maybe, and then these are the particles y, because we had seen in the different types of reactions, we had seen that sometimes more than one particles are also emitted. Fission is a very special case of a nuclear reaction. This happens like this, and as we already know from our previous knowledge in our schools that a large amount of energy is released, and that is why it's so much studied and so much it is required. Because let's clean the board. So suppose I have a uranium nucleus, I hit it by a neutron like this. What happens? This breaks up into small parts, barium and krypton in this case, and then release of 3 neutrons, and of course lots of energy. Now students, this is we have drawn a nucleus here, we have drawn an uranium atom here, and we have shown that it has been broken into barium and krypton. But let us consider the real case. In real case, we don't have a uranium nucleus all alone. Definitely it will be inside a piece of uranium. However small you may take this piece to be, you will see there will be millions of uranium atoms here. So what will happen that in the first, suppose there is a new uranium atom here, the nucleus comes and hits it. As a result, we have seen that 3 more neutrons will come out, and obviously these 3 will, since they are inside the block, they will hit another, each one may hit uranium. So what will happen that again there will be 3 neutrons, again they will hit it. So you see at each friction, at each fission, as we have seen, a large amount of heat is generated. So you see, and I forgot to mention one thing, in the first hitting or the first breaking, how much time does it take? It takes 10 to the power minus 9 seconds. So you see, for this uranium fission to occur, such a small time is required. So in a very small time, you see these 3 neutrons will be generated, and then they will go and hit another neutron. So in a small time, not even a second, you see so much energy will be evolved, and so this might lead to an explosion. So that is the one of the points that is important for us. Secondly, the energy evolved, if it can be used in a useful manner, then it will definitely save the energy crisis. So these are the 2 points for which nuclear fission, study of nuclear fission is so much studied all over. And after that we move on. We have done these things in our school. In fact, we have seen that if it is used, nuclear fission is used in a useful manner, we have nuclear reactors. And otherwise, if we don't control them, then we have nuclear bombs. We have nuclear bombs, because there's every chance of an explosion taking place. So these are the things, some of the things that we already know, and today we'll go to things which perhaps we have not learned earlier. So one of these is the fission fragments. Distribution of Now students, when we write this equation, uranium 235 plus neutron goes to form barium and krypton. When we write like this, it appears as if plus neutron. So when we write like this, it appears to us as if whenever I have a block of neutron, because you cannot have a atom alone, so what will happen? It appears as if this will always, you hit it with a neutron and it cleanly breaks up into barium and krypton like this, two parts, as if this is the uranium hit by a neutron and it breaks up into two parts like this. One will be barium and one will be krypton. No, this is not the case. This does not happen. It does not always happen like this. You will see that so many things can happen, because you see you have barium is how much? It is 141. I am talking about the mass number because it's the mass number which is written on the top. And this is 92 krypton, and this is how much? 235. And you will see that, and again we have here 1, and this is 3 times. So you will see that 141 plus 92 plus 3 into 1 will give us 235 plus 1. 235 plus 1. Because as we had seen, for conservation, there has to be a conservation of particles, because you see the number on the top denotes the number of particles inside the nucleus, so this has to be satisfied. So it might happen that this plus this will not always give me, this plus this, on which has to be written on the left hand side, will not always be 141 and 92. It may also be like this, 140 plus 93, or it may be 139 plus 94. So correspondingly we may have elements whose mass numbers are this also. If this thing is not clear to you, we'll go to a graph which very nicely explains what we mean by fission fragments and how they are distributed. So we'll again clear this board. So if we draw a graph, between the mass number of fission fragments Now what do you mean by fission fragments? It is the two parts into which the nucleus of uranium has been divided, and this side, the percentage yield. Now I'll just explain what is the percentage yield. What is the percentage yield is that it is the amount of that particular mass numbered part which has been collected. That means, suppose I have a block of uranium, I let it undergo fission. That means I hit it with a nucleus, and then there will be a large number of fissions. See, this is just a theoretical work. It's not possible to collect the parts. So if you collect the parts and you draw a graph between how much a particular mass numbered element has been emerged after the fission, that means I hit this with a neutron and then they break up into two parts, different types of parts I will have, not always barium and krypton, and I collect them. Suppose this is barium, and of the total parts, what is the percentage? Suppose there is 10,000 different parts have been collected. Out of the 10,000, actually we will have to collect all the parts. Then I take the parts